Hello. Good morning to all. Can you hear me?
Yes, sir.
Very
Yes,
good
sir.
morning to all. Yes, in continuation to the last class, we have been discussing the important questions designed by the Board of Intermediate. Yesterday we have completed the VSAQs, and today already some of the SAQs also we have discussed earlier. And most of the times, the students may not touch the problems which are attached to the LAQ or which may be given in SAQ also. I want a video. It's okay. Okay. Now coming back to the problems which we are given in this. Yesterday we discussed about the 22nd problem in short answer questions. Anybody can see that? Yes. Can you see the board? What is the 22nd question, please? Hello. What is the 22nd question which is on the board screen? A pair of adjacent coils has mutual inductance of 1.5 Henry. If the current in one coil changes from 0 to 20 ampere in 0.5 second, what is the change in flux linked to the other coil? It's not flux linkage, flux linked to the other coil. So what is the formula to be used? What is the formula to be used?
M into di by dt.
E is equal to minus m into di by dt. And here, what is the M? Mutual inductance, 1.5 Henry. Current changes from 0 to 20 ampere in 0.5 second. Okay, so E is equal to minus 1.5, 20 minus 0 by time, how much time? 0.5. 0.5 can be written as 1 by 2. That's nothing but E is equal to minus 1.5. 20, this 1 by 2 goes to 2. So it becomes 40. So E is equal to minus 6 volt. But he didn't ask E. He has asked the change in flux. As you know, according to the Faraday's second law of electromagnetic induction, E is equal to minus d phi by dt. E, we got it as minus 6. And he's asking d phi. So minus d phi, that is the change. Dt is again 0.5, that is 1 by 2. So you can say that minus minus get cancelled. D phi is equal to 1 by 2 into 6. So d phi is equal to 3. May I know what is the unit of flux? Magnetic flux? Weber.
Weber.
So d phi is equal to 3 VB. This is the what we had discussed. It's okay. Next, going back to the problem, you can do 23rd one. In the same process, you can do it. What is the 23rd problem? Please. What is the 23rd problem? Students have to respond. Request. Current falls from 5 to 0 ampere in 0.1 second. If average EMF 2000 volt is induced, give an estimate of self-inductance of the coil. So, what he has given, what is the change in current? 5, 0 to 5. What is the dt? 0.1 second. Then EMF is 2000 volt. Then self-inductance. You know that E is equal to minus L into di by dt. DI, you can write it as even minus also. Negative sign indicates it decreased from 5 to 0. So you can say that E is equal to minus, sorry, E is how much? 2000. You can write it as 2 into 10 to the power of 3 minus L into DI is minus 5, decrease in current, DT is 0.1. Now you'll get L is equal to 2 into 10 to the power of 3 into 0.1 by 5. How much? Anybody? 2 into 10 to the power of 2 by 5. That is 200 by 5. That's nothing but 4000. Check the answer once again. Can you able to see the board?
Yes, sir.
Yes.
Sir,
Yes, please.
E is equal to 200 volts, sir.
E is 200 volt. Sorry.
Yes, sir.
Oh, I have taken by mistake. I have taken. You let it be 200 or 2000. By mistake, I have taken 2000. That's a 200. It becomes 2 square. 2 square. Instead of 40 Henry, you'll get 4 Henry. Okay. No problem. 20 by 5. Is it? Okay. Then coming back to that. Yesterday we discussed about the gates also. Now straight away I'm coming to the long answer questions. In long answer questions, everybody knows what is a Doppler effect, and you have to see the derivation of Doppler effect. The long answers. It's okay. Now, what is the Doppler effect? Obtain an expression for apparent frequency of sound heard when the source is motion with respect to it. As you know, Doppler effect. What is the Doppler effect? The apparent change in frequency of sound due to the relative motion between the source and the observer is known as the Doppler effect. You go through the derivation for it. We can say that we derive it. This you remove it. This total remove it. Okay. Now, you can see that n dash is equal to n into V minus V naught by V minus Vs. As you know, n dash is the apparent change in frequency. N is the true frequency or original frequency of the sound produced by the source. V is the velocity of sound. V naught is the velocity of the observer. Vs is the velocity of the source. This has been derived by assuming that the source, the observer, and the sound are traveling in the same direction. This is the source, this is the sound, and this is the observer. First of all, to get the sound, you should have the source. So this n dash is equal to n into V minus V naught by V minus Vs is derived on the assumptions that the source and the sound and the observer are moving in the same direction. If anything is opposite to that, you take it as negative. For example, source is moving away from the observer, then Vs you will get. Then Vs is negative. Suppose if you say that observer is moving towards the source, then it is a V naught. Now V naught is equal to negative. This is a very important, not only for the board, even for the competitive exams also. And suppose, as you know pretty well, that if observer is at rest, V naught is 0. If the source is at rest, Vs is the 0 and n dash. In some books or in some publications, instead of n dash, they take it as the nu dash also. and they take it as nu naught also. Nu or n or f stands for the frequency. That is V minus V naught by V minus Vs. Okay. Now, coming back to the problem, attach it to the long answer question, question number 1. Okay. A train sound its whistle as it approaches and crosses a level crossing. An observer at the crossing measures a frequency of 219 Hz, 219 Hz as the train approaches, and frequency of 184 Hz as it leaves. If the speed of sound is taken 340 meters per second, find the speed of train and the frequency of its whistle. Now, where is the observer? Observer is at the railway crossing. So, observer is at rest. So, V naught is equal to 0. And when the train is approaching the stationary observer, when the train is approaching the stationary observer, so I'm taking once again, n dash is equal to n into V minus V naught by V minus Vs. This is the basic formula. Now, as per the problem, observer is at rest, so V naught is 0. And the source, that is a train, is approaching the stationary observer. So you take it as n dash is equal to n into V minus 0 by V minus Vs. So n dash is equal to n into V by V minus Vs. What is n dash he has given? 219. So you take it as 219 n into V by V minus Vs. Take it as case 1. Next case. The observer listens the sound of frequency 184 Hz as it leaves. Means the source is moving away from the stationary observer. Stationary observer means V naught is equal to 0, as we already taken that. Now, you can say instead of 219, we have 184 is equal to n into V by V minus of minus Vs. Why minus of minus? Because the source is moving away from the observer. So you can say that 184 is equal to n into V by V plus Vs. Take it as equation 2. Solving these two equations, you will get the both true frequency and also the velocity of the source. Hope that everybody is following. Okay. If you want, you can 1 minute.
Now join the class. You click the link again.
Okay. I want the board. Coming back to that. Student, hope that you have written the two equations. Solve the two equations. 219 by 184, and it get cancelled. You'll get V plus Vs by V minus Vs. Then solve these, you'll get it. V, how much he has given? 219 by 184 is equal to, V has given it as 340. So 340 plus Vs by 340 minus Vs. You solve it, you will get it. Hope that you can solve later, and roughly you will be getting the frequency of the sound produced by the train, it will be around 200 hertz, and Vs will be around 29 point something. Okay, so if you solve it, you'll get velocity of source as around 29 point something 3 meter per second, and by substituting either in 1 or 2, you will get n is equal to nearly 200 hertz. Yes. Coming back to that third question. It's a very do you have any doubts in this problem? Anybody, please, you can come up.
No, sir.
Thank you. Yes, coming back to the third one. What is the third one? Explain the formation of stationary waves in air column enclosed in open pipe. Enclosed in open pipe. This is a very common question in Board of Intermediate. Sometimes they ask closed pipe and sometimes they ask open pipe. And they attach one small problem with that which carries 2 marks. Most of the students will lose the 2 marks as they won't attempt the problems. But you can, it's very simple. Formation of stationary waves in air column. Just I will draw the figure in open pipe and also in closed pipe. You may be knowing that. Okay. Okay. So here, straight one. Huh? This is another page. This is another page. Okay. Derivation, hope that you can do it. Okay. It takes time to do. Leave it. This they will do it. Okay, we'll go to the problem. Derivation, hope that you can do it. Coming back to the problem. What is the problem, please? A closed organ pipe 70 centimeter long is sounded. If the velocity of sound is 331 meter per second, what is the fundamental frequency of vibration of air column? Is it open pipe or closed pipe? It's an open pipe. Then N1 is to N2 is to N3 is equal to 1:2:3. In case of closed pipe, N1 is to N2 is to N3 is equal to 1:3:5. Now coming back to that, N1 is the fundamental frequency of the air column vibrating in an open pipe. So N1 is equal to V by 2L. In open pipe, it is V by 2L. In closed pipe, it is V by 4L. Please remember. This is a very common question and very important also. They'll have 2 marks. Just you have to substitute. Only the thing is you have to take care that L will be in centimeter. And you know pretty well how to convert centimeter into meter. Just multiply with the 10 to the power of minus 2 meter per second. So coming back to the problem, N1 is equal to, V is how much? 331 by 2 into L, how much? L, how much?
70.
I'm at third problem. Yeah, it is a closed pipe means it is a 4L. So we take 4 into L is, what is the L? 70 centimeter.
Sir, the sum is open pipe, no, sir.
No, say he has asked the derivation for open pipe, but the problem he has given closed organ pipe. So it is a V by 4L. As you said, They have asked derive the equation for the frequencies of harmonics produced in open pipe. But attached problem is closed pipe. A closed organ pipe 70 centimeter long is sounded. If the velocity of sound is, so when it is a closed pipe, what is the formula? V by 4L. Can you hear me? Yes,
Yes, sir.
70 into 10 to the power of minus 2.
Yes, sir.
Yes. Then it will be 331 by 280 into 10 to the power of 2. That's nothing but 3310 by 28. 3310 by 28. Whatever you'll get it. Calculate. 3310 by 28. Do it. How much you'll get it? You can do it. It's around 118 hertz. 118.2 hertz. Even if you write 118 also, they'll give the marks. It's okay. No problem. So that's why, as your people seeing the problem, here he has asked the frequencies of harmonics for open pipe, but the problem attached is closed pipe. You should be very careful. Once again, I repeat, in case of closed pipe, the fundamental frequency is V by 4L. In case of open pipe, the fundamental frequency is V by 2L. L 99% or 100% you'll give in centimeter. You should be very careful in converting the centimeter into meter. Yes, coming back to that. Fourth one. Explain the formation of stationary waves in air column enclosed in enclosed pipe. Derive the equation for the frequency of the harmonic produced. As I already told you, you should derive N1 is to N2 is to N3 is equal to 1 is to 3 is to 5. Here, a closed organ pipe 35 centimeter long is sounded. To the velocity, same thing. Instead of 70 centimeter, you take it as 35 centimeter. Yes. Going to the other problem. Fifth one. State the working principle of potentiometer and explain with the help circuit diagram how the EMF of two primary cells are compared by using the potentiometer. You have to prove that E1 by E2 is equal to L1 by L2. And everybody knows pretty well that potentiometer is a device used to measure the PD between the 2 points. Camera I want. Where is the camera? I want this. Where can I see? Whose face? No, my face only. It's not. Anybody? So E1 by E2 is equal to L1 by L2. Then coming back to the problem, a battery of EMF 10 volt and internal resistance 3 ohm is connected to a resistor. It is a mistake. If the current in the circuit is 0.5 ampere, calculate the value of R. Can I expect the hints from the students? You know that I is equal to E by R plus R. I is equal to E by R plus. What is asking? What is asking, please? Value of R. So R plus R is equal to E by I, and R is equal to E by I minus. What is the EMF here? What is the EMF? Please tell me. 10. What is the
10
current?
volts.
Current 0.5. 0.5, you always try to write it as 1 by 2, so there won't be any calculation problems. Minus, what is the internal resistance?
3
3.
ohms.
So it becomes 20 minus 3. That is a 17 ohm. This is the problem. To the same problem, in March 17th, he has asked a little bit extra one. In addition to the find the value of R, and he has asked the terminal PD also. Means he has asked PD. Here he has not asked, so you take it as V is equal to IR. I, 0.5, 1 by 2. R is 17. Then you will get 8.5 volt, which is not there in the problem, but if he can extend to the terminal PD also, or he can ask the PD. So you know that by Ohm's law, it is V is equal to IR. 1 by 2 into 17, 8.5 volt. Then Kirchhoff's laws, seventh one. Oh, sorry, I'm going to sixth one. I missed the sixth. Can you see the board screen? What is the sixth one? State the working principle of potentiometer and explain with the help circuit diagram how the potentiometer is used to determine the internal resistance of a given primary cell. A battery of EMF 2.5 volt and internal resistance R is connected to resistor 1 ohm. If the again it is a mistake if the correct it is not correct, it is the current. If the current in the circuit is 50 milliampere, calculate the internal resistance. Same formula, you can use it. Use the formula, same formula, and please give me the answer. I is equal to E by R plus R plus R is equal to E by I, and R is equal to E by I minus. Substitute the values, you'll get it. But here you should be very careful. The current is 50 milliampere. I is equal to 50 milliampere means 50 into 10 to the power of minus 3 ampere. That is nothing but 5 into 10 to the power of minus 2 ampere. You should be very careful. It is a milliampere. Sometimes they give microampere or sometimes they give directly ampere. That conversions, you should be very cautious. So you can go for that. Then coming back to the seventh one. What is the seventh one? State Kirchhoff's laws for an electrical network using the laws. Deduce the condition for balance in Wheatstone bridge. A wire. Now this everybody knows that you can go for the In some books, it is proved as P by Q is equal to R by S. In some books, they take it as R1 by R2 is equal to L1 by L2. And while drawing the Wheatstone network, please take the precautions. 2 dots here, like this. It will be in the quadrilateral form. Then join this. I'm not going to derive this one, but I'm telling you how to draw the figure perfectly. Figure also will be having the marks. Just you can say P, Q, or S. The main current comes here. You can say I1, I2. You can say IG, I3, and I4. Sorry. You should be very careful in applying the Kirchhoff's first law, known as the junction law, at junctions B and D. Okay? At B and D. At B, I1 is equal to I3 plus IG. At D, you take it as IG plus I2 is equal to I4. Then remaining, you can go for it. At last, you have to prove that P by Q is equal to R by S. While taking the second law, you take this and you take this. Mention the arrows so that you will never be confused. Okay. So we prove that P by Q is equal to R by S. Is it okay? Next, coming back to the problem attached to the question number 7. A wire of 4R is bent in the form of a circle. What is the effective resistance between the ends of the diameter? Write color code of resistance with yellow, violet, and red colors. Yes. As everybody knows that resistance depends on the length, directly proportional. R is proportional to L, proportional to 1 by A. R is proportional to L by A. R is equal to rho into L by A. Rho is equal to RA by L. This is a very common. Rho is the specific resistance or resistivity of the material of the wire. Or even you can expect a problem on this also. R pi R square by L. R into pi. Radius, as all of you know, that it is a half of the diameter. So you can say that D square by 4L. You can expect the problem on this also. Okay, coming back to this problem. What is the problem here? A wire of 4R is bent in the form of a circle. So when the wire 4R resistance is bent in the form of circle, what is the effective resistance between the ends of the diameter? This is the circle. So you can say that this is the thing, what he is asking. He is asking what is the effective resistance between the ends of the diameter. Now the same thing I can say that here one resistance, here one resistance. Now, What is the total resistance of the wire? 4R. So half of the circle will have 2R, and this is also 2R, because that's why I told you resistance depends on the length. So when the total wire, which is in the form of a circle, is having 4R, and when you take the 2 points diametrically opposite, then you'll have 2R and 2R. The rest of thing you can say that whether they are in parallel or in series. Say that this is A.
Parallel, sir.
Parallel. And you know pretty well what is the formula for the effective resistance when the resistance are in parallel?
1 by R equal to 1 by R1 plus 1 by R2.
Very good. So as you know, all the students will know that 1 by R is equal to 1 by R1 plus 1 by R2. The same thing you can write it as R is equal to R1 R2 by R1 plus R2. Now here R is equal to R1 2R into 2R by 2R plus 2R. How much, please? 4R square by 4R.
4R.
That is R. Is it clear? That's all. Next is the question number 8. Question number 8. What is the question number 8? All of you hope that you can see the screen. What is the radioactivity? State the law of radioactive decay. Show that the radioactive decay is exponential in nature. The half-life of period of radium is 1600 years. How much does 1 gram of radium takes to reduce to 0.125 gram? Anybody is having any doubt in this problem? Please speak out. Please speak out. Okay, we'll do it. As you know, n is equal to n0 into e to the power of minus lambda, that which you are going to derive. Practice it. N is equal to n0 into e to the power of minus lambda. In some books, they write it as, instead of n, they write it as nt also. That means the number of nuclei, the number of atoms present at time t. N0, the number of atoms present in the radioactive substance at t is equal to 0, initial. And lambda is the decay constant. Coming back to that. Coming back to the problem. What is the half-life? T half. Or in some books, they write it as TH also. 1600 years. How much did 1 gram of radium takes to reduce to 0.125 gram? So what is the initial mass of the radioactive substance? M is equal to m naught. Same thing, instead of n is equal to n0 into e to the power of minus lambda t, you can write it as m is equal to m0 into e to the power of minus lambda t also. Okay. How much does 1 gram of radium take to reduce to 1.25 gram? So this is m0 is 1 gram. MT is 0.125 gram. And as you know pretty well, n is equal to n0 into 1 by 2 whole to the power of n. Similarly, m is equal to m naught into 1 by 2 whole to the power of n. N is the number of half-lives. Number of half-lives. Now coming back to that here. M by M0 is equal to 1 by 2 whole to the power of n. M or empty. So what is you have to substitute. 1 gram has become 0.125 gram. Substitute the values and get the n. N is the number of half-lives. Then T is equal to n into T half. You can go for it. Please try it. Please try it. Any response? Any response, please, from your side? Hope that everybody is doing. Can I expect the answer from you? Nobody is responding.
4,800 years, sir.
Pardon?
4,800.
Yes. What is the n you got? May I know?
3, sir.
3. Exactly. This I am taking. 0.125 by 1. 1 by 2 whole to the power of n. By doing the calculation, you get n is equal to 3. Where n is the number of half-lives, then T is equal to n into T half. N is 3. T half, they are given it as 1600 years. So that is 1600. It becomes 4,800 years. That means in 4,800 years, the 1 gram of radium will become 0.125 gram. Yes, please. Then coming back to the question number 9, as I already told you, we are doing only the problems. What is the question number 9, please? Explain the principle and working of a nuclear reactor with the help of a diagram. But everybody can do it. After drawing the diagram, you have to mention the five important points in the nuclear reactor. They are, number 1, what is the fuel? Fuel means the radioactive substance, what you use it. Another is, you have to go for the moderators, control rods, coolant, and the safety system. What are the moderators? Moderators are used to slow down the fast-moving neutrons. What are the examples you can give? You can give the
Graphite rods.
graphite. Yes. Next is control rods. Control rods are used. Oh, what for? Graphite blocks or moderators are used to slow down the fast moving neutrons. Control rods are used to absorb the neutrons. What are the example for control rods? Cadmium, boron, and all this. Then you have to go for the coolant. So 5 important parts of the nuclear reactor are, one is the fuel, that is the radioactive substance which you are using, maybe thorium or uranium. Another is the moderators, another is the control rods, another is the coolant, another is the safety system, reflectors also. Next, coming back to the problem. Calculate the energy equivalent to 1 gram of substance. Calculate the energy equivalent to 1 gram of substance. It's a very simple one. That's nothing but E is equal to mc square. Here we write it as E is equal to delta mc square. E is equal to delta mc. Here delta m is 1 gram into C, 3 into 10 to the power of 8. Everybody knows that velocity of light in free space. 1 gram you convert into 1 into 10 to the power of minus 3 kg and 9 into 10 to the power of 16. How much it becomes? How much it becomes, please? One into 1 into 1 into 10 to the power of minus 3 into 9 into 10 to the power of 16. That becomes 9 into 10 to the power of 13 joules. This is the answer. Anything? Any doubts? Please, you can come out with the doubts.
Sir,
Yes, sir.
sir, can you explain Doppler effect derivation, sir?
It takes time. We have the slot of 1 hour only. It's running up. Pardon? We'll send one more link because this link will have only 1 hour time. As the time is running up. Okay, we'll send one more link for doubts. Okay? Because
Yes,
the slot allotted time for this link is only 1 hour. It takes long. Next. Anything? Please go through the derivation before we discuss in the next link so that you will have a vague idea. And you must know what is the difference between Doppler effect and Doppler shift. As we already discussed, what is the Doppler effect? The apparent change in frequency of sound due to the relative motion between the source and the observer. What is the Doppler shift? The change in apparent frequency to the original frequency. The change in apparent frequency heard by the observer to the true frequency emitted by the source. That is a Doppler shift. Don't get confused between Doppler shift and Doppler effect, but 99% they go for Doppler effect only. Okay, so go through that, and in the next link we'll discuss and we'll derive the Doppler effect as you require. Any more doubts in the problems, please? Any more doubts in the problems which we are given? Anything? All the students? Fine, see you in the next link. Have a good day. Thank you.